Every challenge question, book 2, chapter 4. This is the binomial expansion chapter. I've put the formula that we're going to need down here. You can actually just use this formula straight up on this. You can just replace this x with a 1 over x every time you see it, which is confusing because it asks you for the x squared term, but it accepts a 1 over x squared term is the key idea there. So yeah, just replace this x with an x to the power minus 1 every time you see it, which makes this going to be, well, in the end, this will be an x minus 1, this will be an x minus 2, and so on. I mean, yeah, then just put the numbers in. So the first one is 1, then you have minus a half times x to the minus 1. Then here you'd have minus a half times minus 1.5 over 2, which is apparently 3/8. And then you times those things out and you end up with this. And that's what what they really wanted. Anyway, show that when x is 9, the exact value of this is this. So when x is 9, you have 1 over 1 plus 1 over 9, which is 10 over 9. You flip it over for this negative to make 9 over 10, and then you root to make 3 over root 10, which you can then rationalize to be 3 root 10 over 10. Then we use our expansion to find an approximation to root 10. So we're going to say this thing here is approximately equal to this thing here if you cut off all the terms after that one. So we'll say this thing here is equal to that, and it's approximately equal to, just calculate this. So if you put in 9 into this, because of course we're using x as 9, just put in 9 into this, and you get this. And cut off the other terms, you get that. So now times by 10, and then divide by 3. And then square root, and type it into a calculator. Or sorry, don't square root, just type that into a calculator. And then you've got your approximation root 10, which is 3.16. Okay, next one then, obtain the first form in terms of this. So, of course, 1 over a root is to the power minus a half. We just saw that. And now we're ready to just use this formula again, where every time we see an x, we're going to replace it with 3x squared. And just get this. The first two numbers are the same as the previous time we saw it. We're going to times this one by 9, though, because, of course, 3 squared times x squared squared. But okay, and then this one is just made from minus a half times minus 1.5 times minus 2.5 divided by 1 times 2 times 3. I just typed that into a calculator and got this. And then, of course, times by 27 to get this, times by 9 to get that, times by 3 to get that. And then, of course, all the x's become x squared, x to the 4, x to the 6. That's all fine. And I think that's good to go. Is that the whole thing? That was the whole thing. Amazing.